Welcome to this short series on resistors in series. Here we want to teach how to use the LT-SPICE for simulation of simple circuits. As you can see on the screen, we already have a small network of resistors in series, but we will have to start afresh. Okay. I will walk you through the whole procedure. So we get started. So when LT-SPICE is opened for the first time, you will have an empty window. Then we'll get started with a new schematic. You click on the new schematic, then populate the window with resistors as required. Okay, to rotate, you have to say Control R. So press Control R on your keyboard to rotate the resistors. Then you can also zoom in and zoom out by scrolling your mouse. Alternatively, you can use the zoom out button here. The next, we have to populate the circuit with a voltage source. So you click on the component here and type voltage. We have a voltage source. Rotate it to suit your requirements by pressing Control R. And join the lines by clicking on the wire. To complete the circuit, we need to put a ground for reference. Then join the line also with a wire. Then let's put values to these resistors. Here we choose 10, 20, 30. This is in accordance with the example we had in the tutorial class, and we are using a 20-volt supply. So we want to know the voltage drop across 10, across 20, and across 30. So let's make a reference point and call this point A. So I call here point A, right mouse click, change the numbers to B, right mouse click to C, and right mouse click to D. Then we join it again with a wire, another wire, another wire, and another wire. So before we run the simulation, let's make a little explanation on what is happening here. We have a voltage source of 20 volts and different resistors respectively as 10, 20, and 30 volts respectively. So we want to know what is the voltage drop across 10, what is the voltage drop across 20, and what is the voltage drop across 30. If you use a multimeter to measure across these resistors, the multimeter creates here as a virtual ground, creates this point B as a virtual ground, and calculates the voltage drop across this resistor. But because we are not using a multimeter, we will have to make our reference to ground. And if we're making a reference to ground, this point becomes a voltage divider. And the same applies to this point. But the same processes are all the same, and the result is also the same in terms of functionality. But the numbers are going to be different because the result we will have here is going to be based on a voltage divider method, unless we are using here as a virtual ground, but that is not applicable in this simulation system. So let's simulate. To simulate this system, you click on the Ritoman, and since we're doing only DC analysis, we just take a DC operating point and click OK. So here we have our results. Okay, it appears the result is not showing on the recording. Okay, let's change the simulation method to DC transient and choose a 1 transit point and simulate. Okay, so we have seen a transit point simulator here. So what we have to do now is to find out the different voltages across different points. I have to reduce this a bit so that it enters the window of the recorder. Okay, so we want to know what is the voltage drop across this point. So I'll have to do a right mouse click here. You see, I have this red probe. A right mouse click and place OP. I have 20 volts drop across here. A right mouse click, place OP. I have 16.6 volts. Right mouse click and place OP, and I have 10 volts drop across here. The same also applies if we just click on it. It will be displayed on the transient meter here, more like an oscilloscope. And if we click the next number here, I have 16.6 in blue, and the next point here I also have 10. But because this is not well ranged, so I can do a right mouse click and change the value to 0. Unfortunately, you are not seeing everything I'm saying, but this is just some of the limitations of the recording system. However, we can see that the voltage measured across 10 is 16.6. This is reference to ground. I have said that before. And voltage reference to 10 is reference to 20 is reference to ground. So it's not measuring only the voltage across 20, but voltage drop across 20 and 10 across the two resistors. That's why we have 20, 20, and 10 this way. And in our voltage, when we come to voltage dividers classes, you will see that because the resistance is equal on both sides, the resultant is going to be half of the supply voltage. Okay, thank you very much. This will be that on resistors in series. In the next class, we will look at resistors in parallel.